The chemical industry, connecting the chemical industry with the high-tech industry. It was already mentioned. The chemical industry, they really are at the dawn of a revolution. The big changes have to be made. We have to stop emitting CO2 and other greenhouse gases. So what has to change? Electrification is the first one. And electrification is there where we are looking at. Next to that, we also have to go to different feedstock, that we have to really look to the energy with a low CO2 footprint. All these kind of things we also have to work on. But what we specifically work on is on the electrification. And for this electrification, we focus our work on the use of plasmas. A plasma, you can see, as a cloud with a lot of energy. And this is the energy we use to get the reactions going. So stop burning fossil fuels to get heat and to get the reactions going. We use electricity to get the reactions going. And the first molecule we are looking at is methane. In the chemical industry, methane is a waste gas, especially when the naphtha crackers are being electrified and the methane is left over. This methane at this moment is burned to heat the naphtha crackers. We stop with that. We're going to use the methane to make hydrogen and hydrocarbons, which can be used for the fertilizer production, but also for the polymer, for the plastic production. And actually, it's an old process. It already has been developed in the 30s of last century by the company of Hulse. They made a big factory of this, using plasmas to convert methane and acetylene and hydrogen. This factory has been built, and it's still there. It's operated, but it never has been improved. They stopped with it, developing it. It was too easy to burn natural gas. And that's where we take it up and bring this back into the industry. Using plasmas to convert methane into acetylene, ethylene, and hydrogen. Why do we want to use this plasma? You can very fast go to a very high temperature. This is the high temperature we need. It makes intermittent operation possible. It's an efficient way of heating because you do not heat through a wall, you heat the gas. And that's why we want to use this plasma. On the left side, you see how it's done now. At the moment, natural gas comes in, naphtha gets into to the chemical sites, and the fertilizers and the plastics are being produced, and at many places CO2 is being formed. We want to do it different. We use methane in a plasma, make the acetylene, ethylene, and the hydrogen, again for the fertilizer and the plastic production, and by the waste products, the bio products, and by recycling, we have our feedstock for the methane again. We have to go to true circularity. We have to keep the carbon in the cycle, because in the future, we do not want to use fossil feedstock. We need processes where we keep the carbon in the cycle. So what we are doing in Geleen, we are situated at Gemmelot, at Brightlands Gemmelot campus, actually, which is, we are surrounded by the chemical industry, and together with the chemical industry, we work on this. So we develop the processes, we look to the fundamentals of the processes with the Lure2UL work, but we also develop the, but we also have to develop the process that how it has been done in the industry, and we have to develop the equipment. And there it comes NXTGEN Hightech. And there we combine the high-tech industry with the chemical industry. We can develop all kinds of processes. We have to look to scale up. We have to look to the equipment necessary. Our next step, with NXTGEN Hightech, we work on the second block, so at the bench scale systems. The next block is we're going to a pilot plant where we want to demonstrate it to the chemical industry, where we can sell the technology, we can sell the equipment to the industry. From there on, it goes to large-scale production. And this company, we are founding a company called Toriant. We do this together with SciTech, TNO, and Maastricht University and the campus. And from there on, the technology can be brought to the industry. So what are we doing within NXTGEN Hightech? We go from labs to large-scale production, and therefore we want to define a single unit which can be repeated in the industry to how it should be done, using a plasma, using the high-tech equipment, and bring this to large scale. And with this, we accelerate the scale-up and to make it possible in time, because the climate goals of 2030 and 2050, that looks very far, but it's not. For the chemical industry, the development times are really long. Normally, you have to think about at least 10 years, and we want to do it shorter. The high-tech industry, it goes much faster. So we really want to see if we can speed this process up. We do this with a group of partners. Here you see an overview, and there's several partners of the high-tech industry, but also Shell, who's the end user. We want to use it at the end. So as knowledge institutes, we have Maastricht University, DIFR, and TNO, and a big block of high-tech companies with whom we want to do it. If you want to know more, I'm around, several of my colleagues are around, also from different partners. We have a small demonstrator with a bit of plasma, so go and have a look at it. And if you want to have more information, just come to us and talk to us. Thank you.